The permutation and combination formulas are useful in determining the different number of ways of arranging R objects selected from n possible objects. The difference between permutation and combination is that in permutation, the order of arrangements is important, while in a combination, it's not. So for instance, in permutation, the sequence ABC is different from ACB, BAC, BCA, CAB, or CBA. So there are 6 different ways of arranging the letters A, B, and C. However, for combinations, order is not important. Therefore, these different sequences are counted as one arrangement only. In the permutation and combination formula, the exclamation point is read as factorial. For example, you have 5 exclamation point, we read that as 5 factorial. It's the product of 5 times 4 times 3 times 2 times 1. So on this slide, we show you the formula for permutation problems. We will see how the formula is used and computed in the example on the following slide. Now let's look at a permutation example. A group of 3 electronic parts are to be assembled in any order. How many different ways can they be assembled? So if we refer to the permutation equation, remembering that n is the total number of objects and r is the number of objects selected. So we have 3 electronic parts. That would be our n value, and our r, the number selected, is 3 as well. So we are going to go through here and solve this. To solve this, we've got 3 factorial on the top. Now remember that this is 3 times 2 times 1. 3 times 2 is 6, 6 times 1 is 6. Then on the bottom here, we have 3 minus 3, which is 0. 0 factorial is actually equal to, I can't get that period on, is actually equal to 1. So if we have 6 on the top and divided by 1, we get 6. Now let's look at another example of permutation. Bet's machine shop has 8 screw machines, but only 3 spaces available in the production area for the machines. In how many different ways can the 8 machines be arranged in the 3 spaces available? So in this instance, 8 is our total number, our n value, and r is 3, which is the number that we have selected. So we are going to do this. Okay, so we are going to look at this together and solve this minus r factorial. So we know that the n value is 8. We are selecting 3, that's the r value. So 8 factorial over 8 minus 3 factorial. So this is just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Sorry, that is sloppy. 8 minus 3 is 5, so this is 5 factorial, which is 5 times 4 times 3 times 2 times 1. So let's scroll down here, and if you multiply this top numerator together, you get 40,320. Then the bottom is 120. So when we divide those two, we get 336. So let's go back to our problem now. And it says, in how many different ways can the 8 machines be arranged in the 3 spaces available? 336 different ways.